Let's do a problem about interference of two waves. So we have two identical sinusoidal waves that are moving in the same direction along a stretched string, and those two waves interfere with each other. So the amplitude of each wave is 9.8 millimeters, and the phase difference phi between the two waves phases is 100 degrees. So the question initially is, what's the amplitude ym prime of the resultant wave due to the interference, and what is the type of this interference, meaning is it constructive, is it destructive, or anything else? So since we are looking for the amplitude of the resultant wave, I will apply the definition of amplitude of the resultant wave from the lecture, and that would be that ym prime is equal to absolute value of twice ym times cosine of phi divided by 2. And again, as a reminder, we take the absolute value here because the cosine can have a negative value, but the amplitude of the wave is physically a positive quantity. We can never have a negative amplitude. So only with respect to our choice of coordinates, the amplitude has a negative value, but physically it's a positive number. Okay, so now let's figure out what the amplitude is equal to. So substituting all the information in the formula for the resultant wave's amplitude and keeping the calculation in degrees and also keeping the amplitude of each wave in millimeters, I get that the amplitude of the resultant wave is 13 millimeters. So this interference is neither constructive nor destructive. It is somewhere in between. So the term for that is intermediate interference. Intermediate interference. So the reason for that is because if this was constructive interference, then the cosine here will be of 0 degrees, which will give us a maximum value for the cosine. And if that were the case, then the amplitude of the resultant wave would be 19.6 millimeters. And on another hand, if that was destructive interference, then we'll have cosine of 90 degrees here. Cosine of 90 degrees here, which would give us an amplitude of 0. So this is neither constructive, neither destructive, and again, it's called intermediate interference. Now I can ask sort of the opposite question, and this question would be, for what value of the phase phi is the resultant amplitude ym prime equal to 4.9 millimeters? Basically, this question is a general question that allows us to figure out the phase difference between two interfering waves when we know the amplitude of the resultant wave. So again, I'm going to use the same formula as before. So ym prime is equal to absolute value of twice ym cosine of phi divided by 2, and I'm going to solve for phi here. So rearranging the terms and solving for phi, I get that the phase angle phi is equal to 2 times inverse cosine of ym prime divided by 2 times ym. Now I will substitute the known values and calculate what's the value for the phase angle phi. So an important thing to consider is the fact that we have absolute value here. So therefore, when we start to calculate the phase angle, a plus minus must be included in the solution, because the cosine can have a positive or negative value for the same for the phase angle when it's shifted by 180 degrees, since we don't know whether there is a shift like that or not. So when I replace the values for the two amplitudes in the calculation here, I get that the phase angle phi is plus or minus 2.6 radians. So for those two angles, plus or minus 2.6 radians, when I calculate this quantity here, I'm going to get the same amplitude of 4.9 millimeters.